7.3 hypothesis testing for the mean when we don't know population standard deviation. So this means that population standard deviation is unknown. So no population standard deviation, but we have S, which is sample standard deviation. So we're going to talk about hypothesis testing for the mean when we don't know population standard deviation, but we do know sample standard deviation, or we can find sample standard deviation. So the pattern does not change, just the functions, meaning the patterns from chapter 6, where when we knew population standard deviation, we did the z-test. If we didn't, we did a t-interval. Same thing. So now we're going to run a t-test because we don't know population standard deviation, but we do have a standard deviation. It happens to be the sample. Alright, so if we didn't have any information about the population, then we use a t-distribution just from chapter 6. So we're using that same concept. Let's talk about critical values first, and then we'll get into testing. Alright, so critical value in a t-distribution is t naught. So chapter 6, it was TC, which meant center. But T naught means we're going to have to figure out if it's going to be a left, right, or center. Alright, so we'll identify the level of significance, identify the degree of freedom, and then we're going to find the critical values. Remember, there is a function in your calculator that you can find this, but every calculator does not have it. So table 5 will get us the answer if you don't have it in your calculator. So where is my formula sheet? You can get yours out while I'm trying to find mine. Here we go. So table 5 in appendix B, table 5. We need our degree of freedom. Left-tailed and right-tailed, we're going to use the one-tail column. One-tail row. So if it's a left tail, we're just going to make that T here negative. If it's a right tail, we're going to keep it positive. That's what this means on the sides. This was chapter 6. Now we're in chapter 7. If it's a two-tailed, then you're going to make it negative and positive. And what it does, it goes ahead and splits it pretty much for you. So two tails is here. And this is just reminding you you have a negative and a positive. Okay, so I have those directions here. So if you ever get confused, find your DF. And then one tail is left and right. Two tails means you have both. Alright, using the calculator, if you have it, it's going to be second bars inverse T. Should be about number 4. It's going to ask you for your level of significance. For left-tailed, you leave it as is. This is for everybody. For right-tailed, we do 1 minus the level of significance. And for two-tailed, you have to divide your level of significance by 2. And do the plus minus of this one, or you could do 1 minus the complement of this to find your T naught. So let's practice that. So find the critical value T naught for a right tail test given level significance 0.01 and N equals 17. So I know I have to find DF. So that's N minus 1, which is going to be 16. It's telling me it's a right tail test. So right tail means I'm going to have to do 1 minus in the calculator, or just do the sign that we have on the table. Alright, so let's look at both of those. table 5. Get my table out. DF of 16. So I'm on this row. But then my level of significance is 0.01, and it's a 1 tail. So 0.01. 16. That's 2.583. 2.583. So 16 is a DF. Going down to 16, 2.583. On the right here, this reminds me I have a right tail test, so I need to keep it a positive. .583. Now for the calculator. I'm going to go second vars. So second vars. Inverse T number 4. Remember, everybody does not have this. Since this is a right tail, I have to do 1 minus my level of significance. So 1 minus 0.01. Then my DF. I could do 17 minus 1 in here, or I could just put 16. Either one. With the calculator, it's going to go ahead and give you the correct sign. Okay, so with the calculator, it will give you the correct sign. I'm doing 3 digits because it's 3 digits on the paper. So with table 4, we work with 2 digits. Table 5 is 3 digits, so that's why I try to keep it consistent. All right, for finding the critical values, negative T naught and positive T naught for a 2-tail test. So this means we're going to have two tails. So this is going to be 2 numbers we're trying to find this time. So left is 1 number, right is 1 number. 2 tail means you have a left and a right. So our DF for this is 25. When we go to our table, we want to make sure we look at the 2-tailed row. Going down to my DF of 25. .708, and then don't forget, this tells you on the side what your sign should be. So I need a positive and a negative. So table 5, it only gave me 1 number, but according to that picture, I need both sides. I'm about to write the last problem. So 1.708. Okay. So in the calculator, you're supposed to do both. You're supposed to find a left and a right, but if you find the left, then you're going to automatically find the right. So remember, 2-tail means I have to divide this by 2. So the chart divides it by 2 already for you, but in the calculator, you're going to have to divide it by 2 yourself. And so it's going to give you 1, and you're just going to have to find the other. So this is inverse T. 0.10 divided by 2. And then our DF is 25. Again, this will give us the negative one, but we're just going to make it negative and positive because two-tailed means we have a left and a right. Two-tailed means we have a left and a right. So after you find your hypothesis test, figure out what test you're going to run. Your p-value, don't forget, your calculator will find it for you, but if you want to find it on your own, there is a function in your calculator, the TCDF function, for left tail test. Once you find out what your t-value is, not your t-naught, but your t-value is, you can set it up like your normal CDF. So normal CDF is for Z's, and CDF is for your T's. Okay, and so I have the directions here. Not sure why I started at Z, that D. I just noticed that DEF for some odd reason. So left tail was the previous one. Right tail means you're going to start with your T to 10,000. 0, 1, and then two tail, you do 2 times the left or 2 times the right. Okay, so second bars, then choose not normal CDF, TCDF. To change that in my notes. So TCDF may be different in your calculator, to just see where your TCDF falls. So the p-value, if you want to find it on your own, that's how you find it. Your calculator will give this to you, but some of you all, I know you like to get down to the nitty-gritty and figure out how they actually get those numbers. Okay, so let's go over t-test for a mean. So to calculate your t, the t-test for a mean is a statistical test for a population mean. The test statistic is a sample mean, and the standardized test statistic t is, so you convert your sample mean to a t by using this formula. The calculator will give this to you. The calculator will give this to you. But if you wanted to calculate it yourself, this is how you do it. And of course, I'm going to calculate this for those who like to use, don't like to use the calculator. I'm going to calculate this for you for the problems. Notice your central limit theorem must be met as well. So the sample must be random. And we need at least 30 in our sample, or the population needs to be normally distributed. As well as knowing how to find your degree of freedom, which is your sample minus 1. Sample minus 1. So if you're using the calculator, so not using the calculator means you're going to calculate your t and calculate your t naught and compare it. Using the calculator means we're going to let the calculator calculate our t and our p, and we can choose to test with either. Alright, so stat, edit, and enter your data in if you have an L1. If you don't, you just skip over number 1. And then we go to number 2. Run the t-test. Stat, test, t-test. And I like to put why we're running the t-test right beside this in your notes, so that way when you go back, you'll know why we're doing what we're doing. So we're doing this because we have no population standard deviation, but we have a S, a sample standard deviation. So we have a standard deviation, it's just not population. So what they do is they take the word population out, and the standard deviation that's given only applies to the sample that was run. So when you have a standard deviation, the sample standard deviation only applies to the sample that was run, not the population standard deviation. Alright, if L1 has data, you're going to choose data. If it has, if you don't have data, you're going to choose the stat option. First, we enter the HO in as a number. So whatever number we have for HO, we're going to put that in. then depending on what you have, if you have a if you're doing data, it's going to ask you where's your list, keep your frequency at 1, and then highlight your HA. If you don't have data, it's going to ask you what does your sample mean, what is your sample standard deviation, what is your sample size, and then you highlight your HA. You're going to click on calculate, and it's going to give you your T and P. My pages are off. Okay, I'll fix those later. All right, a used dealership says that the mean price of cars sold in the last 12 months is at least $23,500. You suspect this claim is incorrect and find that a random sample of 14 used cars, 14 is not enough, ding ding ding, sending off lights, not enough, sold in the last 12 months has a mean price of $21,558. The standard deviation $33,350. Is there enough evidence to reject the dealer's claim at level of significance 0.05? Assume the population is normally distributed. Okay, so I did see n is equal to 14. I was a little worried because that's not enough. This is not greater than or equal to 30. But it says assume the population is normally distributed. It says it exactly. So this allows us to do the problem. So we're good. All right, so now we look for a population standard deviation. Let me see if I see one. I see a standard deviation, but this says the random sample of 14 cars has a mean price of $21,558 and a standard deviation of 3,350. So this only applies to the 14. So I don't have a population standard deviation. But I do have a sample standard deviation. It doesn't say sample, but I know it's talking about the sample that was run because it's saying the mean and the sample. I mean, the mean and standard deviation of that sample was that. So that means we're going to be running a t-test. So I'm going to say that one more time. Give me a minute to write that down. So when I read this, the random sample of 14 cars sold in the last 12 months has a mean price of this and a standard deviation. So this is only talking about 14. It's not the population standard deviation. That has to be given to you, and they didn't give it to us. We found out of the 14 cars this. So this is a sample standard deviation. So we tied to the sample. It's not a population standard deviation. In order for it to be a population standard deviation, it has to say population standard deviation is, or the researchers state that the standard deviation in the past studies have been. So it's some information that just pulled from thin air. This isn't pulled from thin air. This was actually run. Okay, so that's why this is a t-test and this is a sample standard deviation. All right, so let's look at the claim now. You suspect this claim is incorrect. Wait a minute. A used car dealer says that the mean price of cars sold in the last 12 months is at least $23,500. At least. So that means that is included in their claim. This is what they're saying. The mean is at least. So this is the minimum. And any number above that. So where does this go? Because this is included, it goes into HA. Good. And what is the complement of at least? So this was going up, so the complement is going to be going down or less than. All right, so we need our level of significance. 0.05. And I like to compare my sample mean. So this is what they're saying. It's at least this. But then when we ran our sample, 21,558, that's not at least what they're saying. But, you know, you have a margin of error, so you don't know how close it is. But that looks a bit far off, so I don't think they're right. But we gotta let the numbers show us. All right. So if you're going to use your calculator and use p-value, you're good. Go straight to your calculator, put your information in. If you want to use the t and t naught to compare, then we have to find our t naught. So first we determine what kind of test are we running, a left, right, or two-tail. Left, right, or two-tail. HA is pointing left. So this is a left-tail test. So that means we're going to leave the level of significance as is. If you put it in the calculator, or we're going to make it negative on our table. So I'm going to put the calculator function in. But I'm going to use the table. The table's just so handy. Alright, so my DF is 13. This is a left tail test. I'm going to the 1, 0.05. 1.771, and again, this is saying negative because it's left. So this is going to be negative 1.771. So now I'm ready to run my tests in the calculator. All right, so if you need to graph, I like to graph. You don't have to graph, because what this states is any t that we come up with that's less than negative 1.771 will reject. If you don't want to draw the graph. Remember, this is a left tail test, so that means we're looking at the left. So any t that's less than negative 1.771 will reject. Or you can draw your graph. I like to draw negative 1.771. It's like right here. So any t that falls in the shaded area will reject. So again, it depends on how you do this problem. It's up to you. You don't have to draw, but if you want to draw, because I'm a visual person, I like to draw and then see where my t goes. And I'm looking for any t that is less than my t naught, because it's a left tail test. So if you're good at just knowing what's less and greater than, you don't have to draw. But me, I'm a visual person, so I like to draw my graph. All right, so let's run this test. So this is a t-test. We don't have any data, so we're going to run the stats. And we want the t and the p. We want the t and the p. And I'm going to calculate the t. For those who don't like to use the calculator, I'm going to calculate t to show you can still work this out without running the test on the calculator, for those who don't like the calculator. All right, so we're going to stat test. We're in the t-test. Again, data means we have L1. Stat means we have all of our information. So I'm going to put everything in. So there's that claim number. Sample mean. Notice it did not ask us for a population standard deviation because we don't have one. We already verified We don't have one. So if you have one on your paper, but you run the t-test, you run the wrong test. Get out. Go back and do your z-test. Okay. Now it's going to ask us for the sample mean. Oh, it did. I already did that. Sorry. Sample mean, sample standard deviation. N is 14. Right here. And then remember that last one is our HA sign is pointing left. So let me make it point left. So we want the T, we want the P. We want the T, we want the P. So T is negative 2.17 or 169, however you want to round it. P is 0.0246. So this T is less than our T naught, so we'll reject if you're just using the logic of is this going to be less than, and it is less than. If you need to graph it, our T is about right here. If you wanted to use the T in the graph. So this is in the shaded region, so we are going to reject HO. So again, it's less than our T naught. If it was greater than, then it would be failed to reject HO because it would be in the white area. If you're using your p-value, remember p-value compared to level of significance is P low. This is 2 cents, that's 5 cents. Yeah, P is low. It's gotta go. Alright, so now for my T people. If you don't like the calculator at all, and you just want to do your T naught and your T, so you want to use your table 5 and your T to compare. Let me show you how you calculate T. I'll just do it over here. Let me do it over here in the corner. I'm right in the room. I can do it up here. So you take your X minus your mean, or your sample mean, excuse me, minus your hypothesized mean. So our sample mean minus our hypothesized mean, or what they're claiming, divided by standard deviation, divided by square root of n. This is for those who want to calculate T and you don't want to use a calculator. You can do this. So you don't have to, so these are long because I'm doing all these steps. Find your way of doing this and stick with it. You don't have to do all that I'm doing. I'm just showing you the different ways of doing this. So that way, whatever's comfortable to you, we're going to stick with. $20,500, okay, divided by 3350, divided by the square root of 14. This is for those who want to use table 5 and your T to compare, to reject or fail to reject. So negative 2.17, same as the calculator. This is less than our T naught. So it rejects. So that means HO is false. HA is true. And remember, we're looking for this to fail. So we're looking for F here, true here. That's what happened. So let me look at my claim. So my claim was false. So that means there is enough evidence. So don't forget, the HO as a claim has a negative connotation, so we reject here and then we accept here. So we're looking to reject. We're looking for it to be false. So there is enough evidence at the, only when we're like running the test itself, at the 5% level of significance to reject the claim, mean greater than or equal to 23,500. And that makes sense. Because this was way lower than what they were saying. They were saying it was at least this, but it was pretty low. All right, last example. My area's crowded today. Hold on. There we go. The Department of Motor Vehicles office claims that the mean wait time is less than 14 minutes. A random sample of 10 people, that's really low, has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes. At level significance 0.10, test the office's claim, assume the population is normally distributed. Okay, that makes me feel better. So n was equal to 10. That was not 30, but this makes it better. It's a low number, but this makes it okay to do. So let's look for our population standard deviation. We don't have one. This says a random sample of 10 people has a mean wait time of 13 minutes and a standard deviation 3.5. That's only tied to those 10. So we don't have a population standard deviation. But we do have a sample standard deviation that we got from the sample of 10. So this means t-test. Alright, so now let's look at our claim. The Department of Motor Vehicles Office claims the mean wait time is less than 14. Less than 14. That does not include 14. That's 13, 12, 11, 10, 9. But does not include 14. So that goes into our HA. The opposite of that would be 14 and greater. 14 and greater. So let's identify our level of significance, 0.10. And let's look at our sample mean. It's saying less than 14. The sample mean came up to be 13. So that seemed like that's right, but I let the math do the work. So it's saying it's less than 14. The answer was 13, but I don't know. We'll see. If you're using your p-value, go straight to your calculator and compare your p-value to level significance. If you're choosing to use your T's, then we have to figure out what our T naught is. So T naught, this is left, right, or two-tail. HA is pointing left again. So this is going to be a left tail. We're leaving level significance as is. And of course, I'm going to use my formula sheet to find my T naught. So 12, one tail, 1.356. Oh, 1.356. Okay. Let me check that in the calculator because I have something else written down. Give me a minute. Okay, 1.35. Oh, I had the wrong, that's what it is. Like something don't look right. Yeah, I had the wrong DF. I was looking at that. Our N is equal to 10, so our DF is 9. I was like, I'm way off. Alright, so DF is 9. 0.10, 1.383. Alright, there we go. Negative 1.383. Even that can go too fast every now and then. Alright, so since this is a left tail test, any T less than negative 1.383 will reject. For those of you who like to not use the calculator, that's what that means. I'm going to graph it because I'm a visual learner. You don't have to. Negative 1.383. Right now we're all ready to run this test. So again, you can run the t-test to get your T and your P. For those who don't like to use the calculator, we can just calculate our T, and we're going to do that in a minute. So t-test, I don't have data, so we're just going to put our numbers in. Stat, over the test, we run the t-test. Our claim is going to be 14. Claim, or HO is going to be 14, I'll say that. 13 was a sample mean. Sample standard deviation was 3.5. Our N was equal to 10. Then our HA was the less than. Let me double check this because I've been making mistakes today. T is negative 0.904. P is equal to 0.1948. 1949, excuse me. So if you're using if you're using p-value to calculate, to run your test, just gonna take this level of significance, compare it. P-value, is it low? Nope, it's high. So this is like 19 cents. Or yeah, 19 cents. This is a dime. So it's high, we gotta let it fly. Our T is not lower than negative 1.383. It's not lower than, it's greater than. So it's not going to reject. But let me graph it. Negative 0.904. It's like right here. That's in our fail to reject area. This means for our HO, it's true. HA is false. HO is true. HA is false. So we want to be able to support the claim, and can we? No, we can't support it. It's support because it's in HA. And it's a no because it's false. So there is not enough evidence at the 10% level of significance to support, again, support because the claim is in HA, the claim mean less than 14. I almost forgot I didn't calculate my T. So let me calculate the T on the calculator. So remember to calculate T for those who don't like to use that t-test. We're going to come up with this negative 0.904. So we're going to take, of course, if you don't use a T, you can just log off because this is the last thing I want to be doing. So we're going to take our sample mean minus their claim, or minus their hypothesized mean, and divide it by our standard deviation divided by square root n. So here we go. So sample mean minus our hypothesized mean divided by standard deviation divided by square root of 14. I'm putting it all in this calculator at one time this time. Why do I have square root of 14? Oh, I was looking at the other one. Sorry, square root of 10. There we go. Negative 0.904.